Hello everyone. Today I would like to share some of my recent insights about this class in this video. The topic I found which is challenge is the kinetic isotope effect. We all know that isotope exhibit the same chemical reactivities such as carbon-13, carbon-12, and deuterium, hydrogen. They're the same. They have the same electron activity, the same numbers of proton, the same numbers of nucleus, and they exist in the same place of the periodic table. So what the carbon-13 deuterium bond does, carbon-12 hydrogen bond does. However, if we replace a nitrogen to the carbon, then this one is totally different thing. So we can know the light isotope can react faster than heavy isotope. This brings this principle KIE. However, right now we only know, the light isotope react faster than heavy isotope. What else we can know? And how can we use this principle to interpret our reaction mechanism? Only by reading textbooks, we only brings more confusion. So I go back to watch our class video, and right now I figure out this concept. First, I would like to talk about the primary KIE. So primary KIE is only if we want to figure out if there is a CH bond breaking in our reaction rate determining step. Or we can say we want to know if there is a hydrogen atom transfer in our reaction rate determining step. Because deuterium react much slower than hydrogen. So we can measure the reaction rates of our target molecular or target reaction, and we can also measure the reaction rates of the counterpart reaction which replace the hydrogen by the deuterium. And the ratio of these two rate constant will always be 6.5. So we can say if the ratio of 6.5, or if the KIE is 6.5, then there's a CH bond breaking in our reaction rate determining step. If the KIE is not 6.5, let's say if the KIE is 1, then there is no such a CH bond breaking in our reaction rate determining step. That's the primary KIE. About secondary KIE, the principle can apply more universally, such as if we want to figure out whether a substitution reaction is SN1 or SN2. The principle is, firstly, we all know SN1 is a leaving group that leaves away at first and breaking the bond. And SN2 is, instead of breaking the bond, a nucleophile will attack the molecule at first. So for the secondary KIE, we use deuterium to replace the attached hydrogen, not the actual breaking bond, but the attached atom. That means breaking the leaving group bonds of the deuterium counterparts will take longer time than breaking the leaving group bonds of the hydrogen counterparts, but not as longer as the primary kinetic isotope effect, because it's not directly, it's not directly in the breaking bond, but it's the attached atom. In this case, if the KIE is greater than 1, that means this one is happening faster than this one, which is normal. So we can know our purpose mechanism is correct. However, sometimes we will see the KIE is smaller than 1, which means the deuterium counterparts can react even faster than the hydrogen counterparts, which is not normal. So that means our purpose mechanism is not correct. Instead, there will be something else. There's not a breaking bond happens. For example, if SN1 is not the correct one, then instead it should be some nucleophile attack the molecular. In this case, there's no difference between the hydrogen counterparts or the deuterium counterparts. So we can say if we find the deuterium counterpart react faster than the hydrogen counterpart, which means KI is more than 1, then it shouldn't be a bond breaking. It should be something attack the molecular, SN2. And also, I would like to talk about 3 other difficult concepts I overcome in this class. The first one is I figure out the difference, of those several elimination reaction mechanism. The difference between E1 reaction, E2 reaction, and E1CB reaction. And also, I figure out what is photochemistry. Photochemistry is such a very similar concept as I learned in my instrumental analysis class. But right now, I can use a more organic chemistry aspect to understand those concepts. Thanks for listening.